My name is Antoine Allanore. I'm a faculty in the Department of Materials Science and Engineering at MIT. My area of expertise is metallurgy and materials processing. We have developed a completely new way of converting and recovering non-ferrous metals, in particular copper, using a very different approach than what is done right now. And the approach we are taking allows to integrate with more electricity in materials processing and extraction. We have reached a scale that is soon ready to leave an MIT laboratory. We are at a scale of around 100 tons per year of capacity of making and extracting and recovering non-ferrous metals from various sources using a sequence of proprietary concepts that have been practiced in the past, but never really for the challenges of today's world, where we have issues around impurities that are coming with natural resources that we were not seeing before at such a high level. An example being arsenic in copper minerals. And the way we have developed this sequence of processing in each of the steps is to have the flexibility to adapt to different streams. That is to say, while we have developed this technology primarily for copper production in the USA, the technology can adapt to different type of ores. That is to say, it could be translated in South America, in Africa, as well as certain recycling streams, which are today notoriously difficult to process, in the sense that usually recycled products right now, in particular for copper, are typically processed in a primary smelting facility, with some challenges going on with that, in the sense that if you don't have a primary metal extraction facility, you cannot easily recycle the products or the waste that you are generating. One of the challenge of metal extraction and recovery is the cost of production. That is to say, society pays a very little amount of money for most of the metals that we are using. And that means we have to produce these metals at a price that is cost competitive. And one of the way typically the price of metals have been kept down is by having inexpensive labor and automation. Now, automation has reached pretty much the extent that it could get. And as we know, labor is poised to get paid to the value of labor, which means it's high. It's a high cost by definition for any place in the world. So at the end, we are left with the idea of where are we going to be able to reach the next transformation in metals extraction. And what we are arguing and we are developing is the usage of cheaper sources of energy. If you look at the typical breakdown of the cost of metals, it's 1/3 the raw materials, 1/3 the energy, and 1/3 the labor and the other aspects of the plant. So we're trying to target this energy pie, the energy quadrant, by going after electricity. And this may sound historically surprising, but we are seeing that more electrification and the deployment in particular of greener electricity is going to lead to cheaper prices of electricity. And if you have cheaper prices of electricity, then the logical place where you're going to apply this cheap electricity is in intensive sectors where you need a lot of electricity, and metals extraction is well suited for that. So what we are offering in our new development is the ability to integrate this less expensive electricity into metals extraction and processing. Now, if it was just that, it would not necessarily fit what society is asking for. Society is also asking for more sustainable materials extraction and processing. That means less environmental impact. And that's where using electricity, the manner we are proposing it, helps to reduce the amount of waste material that are coming out of the reactor, and allow also to be more efficient in terms of using just the energy needed in order to get the metal out of the stream that is coming in. We therefore have an opportunity to do a two-pronged approach. On one side, using more and less expensive electricity, assuming it's clean, and allowing higher selectivity, less waste generation, and higher product quality than what is available today. And we are always developing this approach so that we have this synergy between the materials aspect, which has to do with the specification, has to do with the selectivity of the process, as well as the cost and societal aspect, which has to do with using electricity and cost-effective electricity. We have developed in the past this approach for iron and steel. You can read some of the news outlets about this, and we are having quite a good success in seeing that technology moving forward in the real world.